So now we have a really interesting question here. A boy of mass 4 kilogram is standing on a piece of wood having mass 5 kilogram. So the mass of this is 5 kilogram. The boy's mass is 4 kilograms. The coefficient of friction between the wood and the floor is zero point 0.5. Wood and the floor is zero point 0.5. Okay, the maximum force that the boy can exert on the rope so that the piece of wood does not move. Okay, see, the first assumption that we need to make here is that rope is pulled vertical, which means the rope is coming exactly like this and not like this. So there is no vertical component of tension involved here. Okay, we assume that the rope is exactly vertical. Now, how do we approach this question? As we do in almost every question, you visualize it, right? You have a frame of reference, and I will here choose frame of reference to be the inertial frame. Then we have systems of the bodies. So we have this complete system. The bodies will be the mass, the block, the boy, and these pulleys. And then free body diagram followed by sigma fx and sigma fy. So free body diagram of man, I'll assume the mass of the man to be concentrated at one point. What are the various forces acting on this? Weight of the man acting downwards, 4g acting downwards. Since this man is pulling this rope downwards, there will be a tension, right? There will be a tension. Give me a second, let me just, yeah. Okay, so there will be weight of the man acting downwards, and then there will be tension acting upwards. Also, there will be normal reaction on, there's a minor mistake here, there will be normal reaction on the man. Because this man is standing on the block will exert a normal reaction on the man, which I'll call it as normal reaction on the 4 kilogram due to 5 kilogram. Okay, sigma Fy is equal to 0. Why? Because there is no vertical motion. So we have tension, both of them are in the same direction. So tension plus normal reaction on 4 to 5 will be equal to 4g. Similarly, for the 5 kilogram mass, there are two reactions. Why? Because this block is in contact with the ground. Therefore, there will be one normal reaction acting on this 5 kilogram mass due to the ground, which we'll call here as R. Okay, and since the man is on contact with the 5 kilogram mass, man will exert a normal reaction on 5 due to 4 plus weight of the body acting downwards. One more time, normal reaction due to ground, and then we have normal reaction due to the man. Okay, so yes, now if when you apply sigma Fy is equal to 0, we get normal reaction on the 5 kilogram mass due to the ground, which is R. You can replace this by R. R is equal to N54 plus mg. But we need to understand that N54 is numerically equal to N45. What is N45 from this equation? Will be equal to 4g minus t. So we have N54 is equal to 4g minus t plus 5. It's not 5mg, it is 5g. So 5g plus 4g is 9g. So we have R is equal to 9g minus t. Now if you consider the sigma fx for this block, there are two forces acting on this block. One is the force of friction which will oppose the motion. One is the force of friction which will oppose the motion. Other is the tension in the string which will be towards the right. Since there is no acceleration is, since there is no movement, acceleration is 0. Therefore sigma fx is equal to 0. Sigma fx is equal to 0. And if tension is more, the block will move towards right. If friction is more, the block will move towards left. If the block is not moving at all, it means that this tension is overcoming this friction. Therefore, tension should be less than or equal to static friction for the block to not move. Static friction is mu s into R. What is R? We found out here, 9g minus t. The value of g is 10. 9 tens are 90 into 0.5 is 45. Minus 0.5 into t. 0.5 into t plus t is 1.5 t. 45 by t. 45 by 1.5 is 30. Okay. All right. So this is an overall view of the problem. Now, what I would suggest is you can take down this solution, in a very easy way. It's hardly 5 minutes. You watch it in 2x. It'll come down to 2.5 minutes, which is some time to understand the question solution and not to solve the solution. Now let's take some more time to understand this solution in detail. Okay. So for that, let's try to visualize this given scenario one more time. So we have a man whose mass is 4 kilogram standing on a 5 kilogram mass. The friction here is represented by the coefficient of friction 0.5. The man is pulling this string down, this rope down. So as this rope is pulled down, this string connected to the block will try to push this block towards the right. However, that motion is not taking place. Why? Because of the friction here. And what is that force the boy is using here? That force will be numerically equal to the tension generated in the string. Okay, this is what we have. Now, let us first consider the block here, which is the man who is pulling the string, and I'll assume that this man can be approximated to be a block. Okay, so this block is representing the man here, and now I can say that this block is being pulled away. This block is pulling down the string, therefore a tension will be generated in the string from the point of contact acting away from it. Tension is developed in this string from the point of contact acting away from it, and we have the block. Now if we draw the free body diagram of the block, if we draw the free body diagram of the man, which is the block represented by blue color here, this is the man here. Excuse me. One force is acting upwards, which is tension in the string. We have acting 4g, the gravitation force acting downwards, the weight, and then we have normal reaction on 4 due to the 5 gram mass, right? Okay. So some of you may have a doubt here. So let me just deviate for a minute and take you through the concept here. See, the normal force between the blocks A and B are in action-reaction pair. What is the action? The bottom block B exerts an upward normal force on the top of the block, on the block which is top of it. Okay, so this arrow represents here normal reaction on A due to B. What is the reaction? The top block A exerts an equal and opposite force downward direction labeled as NBA. So what is this blue arrow? It is the normal reaction on the block due to A. Okay, so this is the normal reaction between two blocks A and B. All right, I hope this is clear, because this is the concept. This is what the question is trying to test on your knowledge. Do you know that do you know to label the component of normal reaction between these two bodies? All right. So if you understood this, I would suggest you make a note of this for one time, and then things will become really clear to you and will stay with you for a really long time. So if you understood this, I can next write down the free body diagram of this man is done. So sigma Fy is equal to 0, right? Sigma Fy is equal to 0, and if sigma Fy is equal to 0, tension is acting upwards, N4 phi is acting upwards, 4g is acting downwards, so we have N4 phi is equal to 4g minus t. So let's use that equation sometime later. And now we'll focus not on the man but on the 5 kilogram mass. So the 5 kilogram mass, there are multiple forces acting on it, both in the x and the y direction. The x direction, static friction will oppose the motion. Tension will be acting away from the point of contact, away from it. Here, two normal reactions are acting. One from the 4 kilogram mass, the man who's standing above it. Second is originating from the ground. So we have second is originating from the ground, which for our ease of calculation, we'll represent it as R. All right. Okay. Now, if we write the free body, if we write the equation of sigma Fy is equal to 0, sigma Fy is equal to 0 simply implies that forces acting downwards should be equal to forces acting upwards. What are the forces acting downwards? Downwards is N54. Acting downwards is 5g plus 5g. Acting upwards is R. The only force is R. But we know that these two pairs are equal and opposite, right? So only the direction is different. The magnitude is the same. Therefore, n54 can be equated to n45. What is n45? We found out earlier to be 4g minus 2. Therefore, I can substitute n45 4g minus 2 t as n54. So instead of n54, I can write here 4g minus t. So this complete equation becomes 4g minus t plus 5g is equal to r. 4g plus 5g is 9g. So we have 9g minus t is equal to r, right? Okay. Now, since this block is not moving, the velocity in the x direction is 0. Therefore, acceleration in the x direction also equal to 0. Therefore, m into a is equal to 0. Sigma fx is equal to 0, which simply translates to forces acting in the left direction should be equal to forces acting in the right direction. Therefore, what are the forces acting in the left direction? The only force acting in the left direction is friction. So we have friction, static friction is equal to force acting in the right direction is tension equal to T. What is friction? Static friction, mu into R. Well, to be more precise, this is not static friction. This is actually the limiting friction, which is equal to mu s into R. What is R? We have earlier found out to be 9g minus T. 0.5 into 90 is 45, 0.5 into T is 0.5 T, 0.5 T plus T is 1.5 T, 1.45 by 1.5 T is 30. That's the numerical part of it. Okay, I think yes, that's this question. See, let me just take a couple of minutes to emphasize the significance of understanding the concept, and not rather, trying to come to a solution or to frame an equation and solve the question. See, it is definitely important to solve the question. It is more important to solve it in a faster method, but that should come to you naturally. How? You understand the given question, you visualize it, then you frame an equation on your own, and the solution part begins this way. The algebraic solution should definitely be faster, right? Because these are just, I would say, silly calculation in terms of a JEE level exam. But what we need to understand is solving this is not the part. Framing this equation is not the part. Arriving at this equation through the given concept, through the